Hello friends, welcome back. In this video, I thought we'd work on our VM. We'll actually have something to execute these instructions. So far, we've just been compiling them into instructions for some future stack VM, but let's go ahead and build a VM that just executes them in Rubyland. This isn't the final thing that I want to build. I might want to compile to WebAssembly or C++, or maybe multiple backends. I'm not sure. So for now, I'm just going to build a VM. Just so I just want to see something execute and see see code running. And so I think that'll be the simplest thing for this video. And first, though, we need to do a little bit of housekeeping because what I've been doing is running this little script to run our specs, but we need a new VM spec. And so what I want to do is do a rake file, and then a task called spec do, and it will require relative spec all, and then spec all RB. I don't know if this is the best way to do this, but it will probably work. Relative compiler spec and VM spec, and then edit compiler, save as VM spec. Okie dokie, and I guess we'll need both a VM and a compiler for this. Let's also make a spec helper so that we can put all of this in there. All of it, yeah. Require relative spec. Just a little bit of housekeeping, and then also compiler spec will do the same thing. Okay, and then over here, we'll do this, but we'll do rake spec. Okay, can't load VM, that's right. We don't have a VM yet. Lib VM.rb class VM. Does that work? Yes. I did that thing again. Somehow. Okay. Don't know how I did that. How? What am I hitting? I'm hitting Control O or something? I still don't know what I did. Control B O jumps to the other pane. I always think of O as other, but somehow I'm hitting it so fast that it's swapping the panes. If somebody knows, maybe I'm hitting Control B O. Oh, that's it. Wait, that's the same thing. Control B O, Control B O. Oh, if I hold Control the whole time, Control B, Control O swaps them. Fascinating. Well, I learned something new about Tmux. Sorry about the little diversion. So we want. Oh man, what is happening? Somehow I have gotten into like a selection mode here. There we go. So we need a VM spec here, and we'll say run code instructions, and then we'll do vm.new instructions dot run, I guess, and what kind of thing here? We want evaluates integers. It evaluates integers. Okay, is that the right verb? Maybe. So let's say run 1 must equal 1. And we'll focus this test. And we'll run our little script. Wrong number of arguments. VM spec line 4. Okay. VM spec line 4 code. Because this does not take an argument yet. Initialize. instructions. Header reader instructions, and then def run. And this will just return nil to start. Wrong number of arguments. VM spec 4. Run vm.new instructions compile. What am I doing wrong? 4. Given 0 expected. Is that I wonder if that's a mini test thing. Maybe you can't have a thing called run. Ah, there it is. Okay, so you can't have a method called run because that's something used by mini test. Fair enough. So we want this to return 1. So I suppose we could loop over the instructions. Each do instruction, and then we could say execute instruction. Private def execute instruction. Oh, you know what? In the last video, someone asked me to make the font size bigger. We'll see what we can do. Oh my goodness. I hope that helps you. That is just humongous. I wonder if have I done it too much? Okay, let's go with that. I think I can live with that. Ugh. Okay, yeah, we'll go with that. I'll try. Execute instruction. So case instruction when the instruction dot I forget, what are our things? We have name, arg, extra arg. Okay. Name, when it is push int, we need to do something, and we need a stack for our stack VM. We'll say stack.push instruction.arg, and then whatever is run, we will use the last. We don't have a print statement yet, so we'll just use whatever's on the stack, the last item on the stack, as the return value, and hopefully that works, except on line 11, instruction, I pluralized it. Okay, so we have a passing test, VM spec. Let's go do it evaluates strings. We'll say execute must equal foo. Focus that and see if that one, can we focus both of those? Very good. Over here, we need to say else raise unknown instruction. Yeah, inspect. Very good. So when push string, I'm going to do the same thing here. Just push the argument, and actually we don't even need separate clauses for that. We could just do it like this. Very good. Focus. Okay. Evaluates focus, evaluates variables, set and get. So execute. I don't like the word evaluate versus execute. Executes, evaluates. I don't know. I'm just going to leave it. So this should be a 1. And I'm just going to go ahead and go down the list here. Execute. I may not even want all of this stuff done right away, so I might just end up deleting some of these tests. But this one is supposed to be 2. Is an error, variable type changes. Don't think we care about that test. Method definition, we do care. Evaluates. Don't actually care about this one either. Sorry, I'm just kind of making it up as I go here. So evaluates method definitions. This should be. let's just execute foo. And we'll say that this should equal foo. With arguments, this one will also just execute foo. And this must equal foo. And don't care about the raising the argument or the raising the error. Okay, very good. And we can skip this test, and get rid of these focuses. Okay, so now we have one failing test at a time. We can do a set var, and we also need, just like in the compiler, we had a scope stack. We're probably going to have the same thing here, vars. And set var is going to do, let's say vars def scope at scope stack.last vars scope.fetch vars. Now we can say vars instruction dot what do we have here? To what do we have here? We have the type as an int. We're ignoring types for now. Instruction set var a. So the argument is the name of the variable, and the value is whatever is popped off of the stack. So we'll pop the last item off the stack and set that in the variable. Cool. Does that get us something? Push var. Oh, that, yeah. Wait, I was working on set var. Yeah, now I need push var. Push var is just the opposite. So we do at stack.push vars arg. And let's do a fetch here so that we get some better error and we don't get a nil by mistake. Okay, we'll go back here and get rid of our skip. So now we have another failing test. Unknown instruction def. When def, we need a place to store our methods. Methods. These are actually functions. They're not methods yet, but down the road they'll be methods. We'll have real objects at some point. At least that's my thinking. Let's print the instruction to H. So we know the name, and we know the index. We will know the index. Each with index. So we could say that the methods instruction arg is the name of the method, and it starts at index +1 is the first instruction to execute. I think that's what I want, is I want to be able to jump to that place. Yes. And then I think we need to while instructions index dot name is not equal to end def, or let's change the while to an until we're at the end def. Then I want to do index plus equals 1, and then let's print which instruction we're on at this point to H. Okay, wrong number of arguments given 1, expected 2, 20. I didn't pass the index here. Unknown instruction end def. Okay, so when end def is just a no op, nothing really happens. Oh, but this is what we were printing right here. We got to the end def, And I believe, I think we want to go one more, which I think means this doesn't even need to exist. But it does exist. Oh, because I'm not updating the index. Okay, so I can't really do this. I can say index is 0 while index is less than instructions.size. I have to kind of do this a little bit more manually. Index plus equals 1. Oh, and that means we don't need this plus equals 1. Instructions index. Okay, I think that's right. Then we can say let's make this an instance variable. That way we can manipulate it down here. I think that's right. Print index. Number of arguments given 1 expected 2, 23. Don't want that anymore. This needs to be an instance variable. Unknown instruction call. Very good. So I think that we're good there. We printed this. Good. And then when call, what is the instruction? What do we have here? We have call, the name of the method, and then the number of arguments. Okay. So the method is at methods instruction arg. And we'll do a fetch here just in case it doesn't exist. Let's print the method. What do we get? We get the instruction pointer. So this is index. So we're just going to jump to that index. But this index plus equals 1 is going to mess us up. I could do -1. Oh, that's gross. That's really gross. But why? End def. Why did we get to end def? Because no. This would be the next index. So let's print every instruction here and the index as we go down. Okay, so we are here. I'm going to focus this test so that only that test runs. So we're at, let's print all the instructions as well. H. Okay, so we're at the 0th instruction, which is a def. After that one executes, we come back and we're on instruction 3, which is a call. Oh, that's working. That's working perfectly. Because after that instruction executes, we jump to index 1, which is the first instruction in the method. And then we get to indef. And indef should be a return. It's beautiful. It was working exactly like it should. When end def. Now, maybe we should have an explicit return statement, but for now, we're already at 20 minutes here. I'm just going to say that, and we need a call stack, of course. So we need a return instruction, a return, return pointer, right? So we'll say this is the call stack, and we'll do call stack is our current index. And then when we are returning from a method, we'll do at index is at call stack dot pop. Maybe. And it passes. Look at that. Oh, that's beautiful. And we got the return value, which was placed on the stack, and it worked just right. So let's do this one differently. Let's make this an integer, make this a 1, and make this a failing test. Push arg. Okay, so this is getting a little more interesting. If we first look at the call, let's focus this test. We first look at the call and we look at the instruction 2h. We have 2 arguments. So we'll do args as an array. Actually, args stack.pop and then the number of arguments, instruction extra arg. That's the count here, the 2. And we'll just print those out and make sure that looks kind of like what we would expect. Yes, a foo and a 1. So I suppose in the call stack, instead of just putting the return address, we could do return here, or let's say ret. Return index, I don't know. Yeah, return index is good. And the arguments for this method call is args. And that means up here, we need to say fetch ret. Okay, so we're still gonna have the same problem, but at least now we have some arguments. So when we do push arg, we're gonna say print call stack.last. That should show us the arguments. Yes, it does. And let's print the instruction as well. So the instruction is push arg and then the index of the argument. So we'll do stack.push or stack. Am I doing dot push? I am. Okay. Just be consistent. I'm mixing them. I'm mixing them. That's really dumb. Let's not mix push and the little arrows. Push call stack dot last dot fetch args and the index instruction dot index. That pushes the argument. Oh, it's not index, it's arg. And key not found ret. Okay. Oh, return index. Return index. Good. Ha yes. Fantastic. We have a little VM that executes everything that our compiler knows how to compile. Integers, strings, variables, and method calls. And let's just do a little something extra here. Say def bar x. We don't have much else we can do right now, but we could chain our method calls just to prove that that works. So if we call foo 100 or whatever, we should get back 100, right? Because it calls foo, it passes bar b to bar, and bar just returns x. So key not found bar. Oh, because I declared them out of order, maybe. Is that why? Yeah, fascinating. That's something I'll try to fix in the next video, maybe. Is why those have to be declared in a certain order. It's probably something about our dependencies. That's okay. We will just call this good for now. Okay. Man, that was a lot of work, a lot more than I thought. I thought we'd be doing a quickie video, but now we have a VM to execute our code to see something happen. That's pretty cool. We'll say day 9. And that's it. That's it for this one. In the next video. So what I'd love to be able to do is my kind of, I don't want to say end goal, but oh my goodness, there we go. I was trying to get to here, and I was trying to get to examples fib. So I'd love for our little language to be able to do this. So maybe not this stuff down here, but the Fibonacci recursive, classic Fibonacci thing. So we need if statements. We need some operators like equality. We need math like plus and minus. And I guess that would be it. I think the recursion is going to be a problem because you saw we couldn't call a method before it was defined. So probably this is going to be a problem. So we'll have to work that out as well. So that might be over several videos, but that's kind of what I'm working towards. So I hope that you'll come back in a future video. Hopefully that's tomorrow, unless something happens to me, but that's the plan. I'm just going to keep tinkering on this, and I hope that you're having some fun. I really hope that you have your own project to tinker on. That's usually my goal, is to just inspire people to build your own thing. I think it's a lot of fun, and I don't like keeping it to myself. I want to share it with everyone. I hope that you can see that that it's a good time, and I guess that's all I want to say about that. I hope to see you soon. Bye.